It's that time of year when, like it or not, holiday music is being piped into every mall, grocery store, and gas station. If you're sick of it, sorry, I wish I could help. What I can do is shed a bit of light on the science of music. See, we here at SciShow have talked quite a bit about music over the years, from whether you can become Mozart to whether your cats like Jingle Bells as much as you do. First, let's focus on something happy, like the music you really love. If you've ever gotten actual chills listening to a song, you're not alone. It often happens with music you adore, and researchers think they can explain why. Here's Stefan to tell us more.
If you've ever been listening to music and suddenly felt a shiver, like a kind of strange chill that runs along your spine and makes the hair on your arms stand on end, congrats! You've experienced what some people call a skin orgasm. Scientists prefer the term frisson, which is French for shiver, and they happen when your body has a strong emotional response to something, like a powerful stretch of notes in a song. But not everyone experiences them, and scientists think that might have to do with small differences in our brains. A frisson is more than the tingling in your spine. While that chill is happening, the electrical conductance of your skin increases because of small changes in your sweat glands. Your pupils also dilate, and brain areas associated with pleasure and euphoria activate as the neurotransmitter dopamine is released in your brain. All of these are the physiological side effects of turning on the neurological reward system that makes you feel good, the same one triggered by things like food, sex, and illicit drugs. But why this reward system is turned on by music is less clear. Sudden jumps from a quiet note to a loud one, or from a low note to a high note, often trigger frissons. Unexpected solos, harmonies, or sequences in melodies can as well. That might be because those characteristics in music are pleasant surprises, and new or unexpected stimuli can trigger your autonomic nervous system, the part of your nervous system that deals with all involuntary physical activity in your body, like how fast your heart beats. But what elicits a frisson also varies from person to person, depending on personal tastes. So scientists think your emotional connection to the piece also plays a role. You're much more likely to have one while hearing a song that you like than one that you don't, for example. And they don't just happen with music. They can happen in response to visual stimuli like pictures or movies. You can even have a frisson just by thinking about an emotional event, but not everyone gets them. Studies suggest that between 55 and 86% of people experience frissons, and a personality trait called openness to experience might explain why. People who score highly on that trait often experience intense emotions, have active imaginations, and are intellectually curious. And according to a 2016 study of 100 college students, they have frissons more frequently when listening to music. The study authors suggest that might be because they're processing the music in a more cognitive, attentive way, which makes them more likely to be emotionally moved by something unexpected in music. Another 2016 study of 20 people added to that by comparing the brains of people who experienced frissons with those who do not. People who do had more connectivity between the auditory cortex, the region which processes sounds, and emotional processing centers in the brain, like the insula and medial prefrontal cortex. If you're not sure if you've ever had a frisson, well, a devoted subreddit suggests listening to Imogen Heap's Hide and Seek or Comfortably Numb by Pink Floyd. Those songs seem to give lots of people skin orgasms. Happy listening!
Wow, Stefan, that's not quite how I'd describe chills, but thanks for the explanation. But while there are some common features to songs that make us shiver, it's safe to say we have pretty different tastes in tunes. And that has a lot to do with our parents. Let me explain.
Have you been getting in formation with Beyoncé lately? Or maybe you're more of a deadhead and think the 70s were the peak of music. A lot of debates about a so-called golden age of music come down to personal taste. But can science help explain where your music taste comes from? According to some psychology research, it's probably linked to your memories of different songs, so there's not just one era of timeless tunes. Developmental psychologists have noticed that the memories you form as a young adult tend to stay more detailed, even as you get older. So, in the late 1990s, some researchers wanted to see if this pattern was also true for memories of music, and if that affected people's music tastes. To do that, they collected a library of songs, with one that was popular in each year from 1935 to 1994. Then they rounded up some elderly people and college students, played them 20 seconds of each song, and asked if they'd heard it before, if they had memories related to it, and whether they liked it. The older group liked the songs that were popular when they were teenagers best, while MC Hammer wasn't exactly their cup of tea. And that's basically what psychologists expected. But the younger group was kind of surprising. They liked the songs from their teenage years best, but they also recognized and liked popular songs from the late 1960s, before they were even born. At the time, researchers argued that the late 1960s was the golden age of music, since even the kids with their newfangled newfangled grunge were still listening to those songs. Case closed. Right? Well, not exactly. Good science means trying to replicate results. So if that was the golden age, other psychologists would see it if they ran the study again. A decade later, some researchers did just that, using audio clips from the top 2 singles from the 1955 to 2009 year-end Billboard charts. They only tested college students and found a similar pattern. Only this time, the golden age seemed to be in the early 1980s, not the late 1960s. These psychologists drew a different conclusion, because they also asked how old the students' parents were. And the golden age songs were from when their parents would have been teenagers. Somehow, the parents were passing their music tastes on to their kids. But it's not like there's a funk gene or a new wave gene that you can inherit. Instead, it's probably an example of the mere exposure effect. Basically, people report liking a thing more when they've seen it or heard it before, whether it's a song or even just random shapes. And it's especially true when they're not paying close attention to the thing at first, like if parents played their favorite songs around their young children. So there probably never was or ever will be one golden age of music, but there's likely a golden age for you.
Now that I think about it, all that kind of explains why so many carols from the 50s just won't die. And it must be so much worse for the people who can tell that the high note in that one recording that's played over and over is just a little bit off. I'm talking about people with perfect pitch, of course. And it seems like those who have it picked it up in childhood. But as Hank explains, it might be possible to learn.
If you heard some random music notes, would you be able to figure out what they were? Like, could you just tell that this is a D and that this absolutely an A flat? Maybe you're just great at guessing, or you could have a rare ability called perfect pitch, which puts you in the same club as Mozart. Perfect pitch, also called absolute pitch, allows you to identify musical notes without context, which is especially helpful if you are a musician. Most research seems to say that you have to learn it as a kid, but with lots of practice, it might be possible to develop sort of perfect pitch as an adult. Many studies suggest that to have perfect pitch, you need to start musical training around 6 years old during a critical period of development. During this time, your brain is figuring out which neural pathways will be useful and which ones it should just get rid of. The key is giving sound meaning, like that this sound is a C, just like learning that the fluffy, slobbery thing that cuddles up next to you is called a dog. Also, if you speak a tonal language where pitch affects the meaning of words, like Mandarin, you could be more likely to develop perfect pitch since your brain has been associating different pitches with meaning from the start. But if you're not actively learning musical notes, your brain will get rid of those extra sound identifying connections so it can become more efficient. Most of this research is correlational, meaning that scientists didn't manipulate any variables and teach babies certain combinations of language and musical notes. But it still makes sense with what we know about how the brain develops. If you missed that critical period of development, researchers aren't sure if you would ever be able to develop true perfect pitch. But some studies have found that adults can be trained to better identify notes, which can last for months. In a 2015 paper from the journal Cognition, researchers tested 17 university students with various musical backgrounds but no perfect pitch, and got a baseline for how well they could name different notes and recreate notes that they'd just heard. Then, the participants went through training where they listened to 180 piano notes and were asked to name them, and then got corrected when they were wrong. After all that, the participants did the baseline tests again and scored at least 8% better, and their scores were still higher for 6 of them when they were retested about a half a year later. This study, and others like it, are pretty small, and the participants aren't all that close to the accurate lifelong perfect pitch that you might develop as a kid. But as long as you're willing to put in the work to learn, it's at least a half step in the right direction.
I guess most of us won't ever be Mozart. Still, you can probably tell if a combination of notes is pleasing or not. Some chords just seem to work, while others sound like nails on a chalkboard. The thing is, while a lot of us dislike dissonance, the effect isn't totally universal. And that can help us understand why it exists in the first place. Back to you, Stefan.
Even if you've never had a single music lesson, chances are certain combinations of notes, called chords or harmonies, sound prettier to you than others. Studies have found that harmonies with note frequencies that are consonant, meaning they're related by a simple ratio, like octaves or perfect fifths, just seem to sound nicer than dissonant ones. Even babies and monkeys react in ways that suggest they share these preferences. But why we like certain musical combinations isn't completely clear. It might be how we're wired, or how we're raised, or a bit of both. Originally, scientists thought our preferences for certain harmonies had nothing to do with us, and had everything to do with the way sound waves interact in the air. When two sound waves are dissonant, they interfere with each other in a way that can cause an annoying wah-wah-wah effect, sometimes called beats. But there isn't a good explanation for why we'd find that unpleasant. And a 2011 study in the journal Physical Review Letters supported a different explanation, that a chord's prettiness or ugliness is all in our heads, literally. The researchers created a simplified mathematical model of how our hearing works, and they set up a simulation of two sensory neurons listening to different tones, which would each send a signal to a third neuron when stimulated. Kind of like how different hair cells in your ears hear different pitches of sound and send a signal to your brain. And the team found that if the two sensory neurons hear what we'd normally call a pretty harmony, their signals arrive at the third neuron at the same time, and the neuron fires once in response to the combined sound. While you're holding the chord, that neuron has time to recharge and send a regular series of pulses. But if it's a dissonant chord, the signals from the two sensory neurons arrive at different times, resulting in an irregularly spaced train of pulses. So the researchers suggest that what we think of as more harmonious just means the sound causes a more regular neural pattern. According to information theory, the mathematical underpinnings of communicating information, regular signals like these communicate more information than each irregular signal does. So it could be that we think they sound better because our brains are able to distinguish and remember those signals more easily. But even though the idea makes sense, the researchers didn't actually test real neurons in real people, and the most recent evidence suggests that musical preferences are more strongly tied to cultural influences. In 2016, researchers surveyed a group of 64 people from the Chimene, an Amazonian tribe that doesn't listen to Western music, and whose own music is entirely based on solo performances and contains no harmony. When they compared the tribe members' perceptions of sounds and harmonies to those of listeners from Bolivia and the US, they found that everyone in the study shared some preferences. They all liked laughter more than gasps, for example. But while the Chimene could hear the difference between consonant and dissonant chords, they didn't prefer one over the other. To them, all chords sounded equally nice. This doesn't mean that the 2011 brain model study was wrong necessarily, just that it's complicated, and both our biology and the music we hear when we're young probably affect what sounds we like.
What we hear when we're young can definitely shape our tastes and our perceptions of music. But can it make babies smarter? Lots of products certainly hope to sell parents on that idea. But here's Hank to explain how one study on the effects of music on the brain got blown way out of proportion.
Parents want what's best for their kids. They want them to grow up to be smart, kind, productive people, and they'll do almost anything to give their little bundle of joy a competitive advantage. Which has led to the strange explosion of the myth that playing classical music for babies might make them more intelligent. You can buy all kinds of classical music for babies programs that supposedly, quote, promote brain development. But there is no real evidence that they will actually make your baby smarter. The idea began with a paper published in Nature in 1993 called Music and Spatial Task Performance. Researchers told 36 college students to listen to either a Mozart sonata, a relaxation tape designed to lower blood pressure, or just plain old silence. Then they were asked some questions designed to test their spatial reasoning. For example, what kind of snowflake a cut-up piece of paper would look like when they opened it up. The study found that the students' average spatial IQ scores were 8 to 9 points higher after listening to music, but the effect only lasted about 15 minutes. But even though this study was tiny and only included college students and found a very specific effect that didn't last very long, the idea was out there. Music could affect the way people think. From there, it snowballed. Articles about the study started to generalize the results, saying that music made people smarter in general. Books like The Mozart Effect and then The Mozart Effect for Children helped spread the misconception. More researchers started to study the connection between music and intelligence. Some studies confirmed the outcome of the original study, but other researchers couldn't reproduce the findings. Meta-analyses that compared the results across all the studies found only a very small effect, if any at all. It's possible that music causes a slight boost in spatial reasoning because music and solving those kinds of puzzles both activate similar parts of your brain. So maybe the music is preparing those parts of your brain in some way, like an athlete warming up before a workout. But even if music helps you solve spatial puzzles, that doesn't mean that it makes you smarter overall. The Mozart effect does seem to help epileptic patients, though. In a few small studies, listening to Mozart's music made seizures decrease. But as with many things in science, more research is needed. So playing a bit of Bach or Mozart for your baby isn't gonna do any harm, but it won't just, magically make them smarter. Things like good old-fashioned talking and reading to your child are much more important for their development.
Alright, so music isn't magic for babies. But what about the less sapient members of your household? Can pets really get in on appreciating a good a cappella rendition of Carol of the Bells? Yes or no? Maybe? Here's Stefan with more.
Whether it's classical, pop, jazz, or hip-hop, almost everyone likes some form of music, but our appreciation of rhythm and rhyme might not be unique. Decades of research have hinted that animals may also be music lovers, and further study of how different species respond to music may help us to understand how and why the ability to perceive and appreciate music evolved in us. There's no doubt that to us, music is different from other sounds. You know it when you hear it. That musical sense is called musicality. And it seems that even animals very, very distantly related to us have it too. One group of intrepid researchers tested whether Nile crocodiles could tell the difference between music and simple sounds. They used a brain imaging technique called functional magnetic resonance imaging, or fMRI, which uses the blood flow in different areas of the brain to estimate activity. Now, if you're wondering how you get a crocodile to kindly sit in a big old machine while you scan its brain, well, these were juveniles less than a meter long. They were also lightly sedated and wearing a special helmet so they didn't move their heads too much. And incredibly, the researchers did see different patterns of brain activity when the crocodiles listened to Bach as opposed to random chords, suggesting the music sounded different to them. And many animals can go a step further and actually distinguish between different genres of music. Pigeons can be trained to peck one key if they hear an organ piece by Bach, and a different key if they hear an orchestral piece by Stravinsky. And even fish can tell blues from Bach. Apparently everyone likes testing with Bach. But this doesn't tell us whether or not they actually like music. To get at that, researchers have looked more closely at how animals react to melodies and beats. In one study, scientists actually created music specifically for cats by using sliding frequencies, a common feature of cat vocalizations, and setting the tempo to the same number of beats per minute as purring. The cats were more likely to turn towards and approach speakers which were playing the special cat music than those playing regular music, suggesting they preferred the feline remix. And just like us, animals seem to find some types of music more relaxing than others. For example, a 2012 study found that 117 kenneled dogs slept more and spent less time barking when played classical music. Heavy metal, on the other hand, seemed to make them more anxious. And studies in primates, elephants, birds, and rodents have all found that at least some kinds of music can chill them out, promote social activities like grooming, or reduce nervous or aggressive behaviors. But being relaxed by something doesn't necessarily mean you enjoy it. Perhaps the most convincing evidence that animals actually like music comes from studies that let them freely choose what to listen to. In a 2007 study, when monkeys were allowed to pick between different types of music by moving to different parts of a chamber, they chose lullabies over techno. But if given the option, they preferred silence. That led researchers to conclude that our relatives just don't like music. But some scientists have since pointed out that most studies use Western genres, and there are a lot of other types of music out there. So in a 2014 study, researchers played 3 kinds of international music just outside of a large chimpanzee enclosure. The 16 study chimps apparently liked West African Akan music and North Indian raga music, spending much more time near the speaker when they were playing. But they were pretty lukewarm about Japanese taiko music. It was a toss-up between that and silence. Taken together, the science suggests that animals, especially mammals, do have some musical preferences. But why do animals like music at all? The answer to that is still a bit of a mystery. In fact, we don't even really know why humans like music. Scientists have a lot of theories about the evolution of musicality. Some think that musicality may be related to our time in the womb. The idea is that we like steady beats and vocalizations because they remind us of our mother's heartbeat and her voice. This would perhaps explain music preference in mammals, but it's less of a satisfying answer for the egg-laying groups like birds. So other researchers think it might have more to do with the importance of understanding vocalizations. Early humans may have used music-like calls to communicate, so being better able to understand the meaning of calls by picking up on subtleties in tone and rhythm could have increased a person's odds of survival. And that could even explain why we find music pleasurable, since our brains
brain's reward system is all about promoting things that keep us alive and reproducing. This hypothesis would also explain why primates and birds have musicality. They also communicate with vocalizations a lot. And it might even mean there are musical preferences throughout the animal kingdom. After all, there are species of fish and even insects that communicate with sound. But ultimately, the origins of our love of music may remain a mystery, as such hypotheses are difficult to test empirically. Fortunately, we don't have to know why musical enjoyment evolved in humans, or in our furry and feathered friends, to be able to rock out together.
Oh my god, I just had the worst thought. Imagine playing special cat music for Fluffy and then having it stuck in your head all day. Luckily, scientists can offer a few suggestions for how to get rid of an earworm, at least until you hear Feliz Navidad all over again. Here's Michael with this essential holiday information.
You're scrolling down your Tumblr dash when you see an impossible piece of news about your favorite TV show. It sounds too good to be true, but you click anyway. And there he is in all his glory, Rick Astley singing about how he's never gonna give you up. You've been Rickrolled, and the worst part is, you know that song is gonna stay with you the rest of the day, a short snippet repeating itself over and over until you want to tear your ears out. You've got yourself an earworm, a repeating snippet of music, probably 15 to 20 seconds long, that's playing in your head without you consciously making it happen. But why? How do songs get themselves stuck in your head? More importantly, how do you get rid of them? It turns out that which song gets stuck mostly depends on the person. But psychologists have some ideas about why your brain puts its playlist on repeat, and there are a few ways to hit pause, including bubblegum and word puzzles. The term earworm entered the English language pretty recently, sometime in the 1970s, by way of the German word Ohrwurm, which means the same thing. But the actual phenomenon of getting a song stuck in your head is much older. Centuries-old references call it the Piper's Maggot. To study it, scientists usually use the term involuntary musical imagery, or INMI for short, because earworms are linked to other kinds of involuntary thoughts. A lot of our conscious thoughts are involuntary, like 30 to 40% of them, but psychologists don't know much about how they work. Within the last 5 years or so, researchers have realized that earworms are a good place to start because they're a little more concrete and therefore easier to study than other kinds of spontaneous thoughts, which first meant figuring out how widespread earworms are, how they happen, and whether some people get them more than others. Earworms are incredibly common. More than 90% of people report having them. The songs usually have lyrics as opposed to being instrumental, and live music is more likely to stick in your brain than recorded music, maybe because it includes a visual element or because you're all excited and emotional from seeing your favorite band right there on the stage. But even though having a song stuck in your head seems like it wouldn't be a good time, that's not necessarily true. Roughly 3/4 of people who report having earworms actually like, or at least don't really care about, the song in their heads. The annoying tunes don't happen as much, but we remember them more because, well, they're annoying. If an experience is more stressful, it's more likely to stick in your memory, which is probably why you remember that one commercial jingle or Rick Astley. Now, if you listen to a lot of top 40, you're probably gonna get a lot of Taylor Swift songs stuck in your head. But you can't get a Led Zeppelin earworm if you've never heard Jimmy Page play guitar. This is why earworms tend to be songs that you know and like. You listen to them more. You might think that certain songs are catchier than others, so they can be more intrusive. Well, that's an easy hypothesis to test, because scientists do know some of the characteristics that make a song catchy. Long notes that are close together in pitch, for example, like in the chorus of the ABBA song Waterloo. In a series of papers published in 2012, a British musical psychologist named Victoria Williamson led a research group that spent some time studying earworms. They asked people to describe the song stuck in their heads, and they found that very few songs occurred more than once. People did tend to report songs like Jingle Bells around the holidays, and pop songs that were constantly on the radio showed up a lot more in the answers too. But every other song was unique, even though they surveyed thousands of people. So which song gets stuck in your head just seems to depend on who you are, your musical taste, and your personal memories. That's because there are a bunch of different ways to get an earworm, and some of them depend on your individual personality. In another part of the study, Williamson and her team partnered with the BBC, surveying radio listeners to try to figure out what gave them earworms. Unsurprisingly, the most common cause was recent or repeated exposure to a song, so Top 40 and Jingle Bells, but there were a few others too. The researchers found that earworms can be associated with a particular memory, and calling up that memory would also dredge up the song. It can even work in reverse, like if you're going to a concert, you might get the band's song stuck in your head ahead of time. Certain moods, like stress or surprise, can make particular songs get stuck in people's brains. They also found that earworms can happen when your mind isn't working very hard, like when you're daydreaming, or even when you're actually dreaming, when you're asleep. Apparently, it's pretty common to wake up with a song already stuck in your head. So we know what kinds of things can cause earworms, but why do our brains get fixated on songs at all? Scientists still aren't exactly sure, but they think it's related to what's known as the Zeigarnik Effect. Bluma Zeigarnik was an early 20th century Soviet psychologist who noticed that servers could flawlessly remember a customer's order right up until the order was delivered. Once the task was done, The memory went kaput. Zeigarnik spent time studying this effect and found that people who were interrupted in the middle of doing something could remember what they were doing much better than people who are allowed to finish. In other words, your brain works hard to keep a task that's in progress in your working memory. But once you're done, it doesn't need that information anymore, so it tosses it out. That can help with productivity, since if you start something, your brain is going to keep it on the front burner until you finish it. In other words, listen to Shia LaBeouf. Just do it! When it comes to earworms, your brain might be considering an intrusive song to be an unfinished task. Also in 2012, one group of researchers at Western Washington University tested this by giving their study participants earworms. They played songs by the Beatles and Lady Gaga and either let them finish or stopped the song in the middle. The songs that they paused didn't come back as earworms more than the finished ones, which would seem to be a point against the Zeigarnik effect, but they noticed something interesting. If participants heard the song playing in their heads right after listening to it, it was more likely to come back as an earworm sometime in the next 24 hours. The researchers interpreted this as evidence in favor of the Zeigarnik effect, proposing that the participants' brains were treating those songs as unfinished tasks. So if your brain thinks it's an unfinished task, how do you get the local car dealership's jingle out of your head? A few studies have come up with different strategies. One of the strangest ideas is to just chew gum, which might somehow interfere with the same processes your brain is using to play the song. Most of the others take into account the Zeigarnik effect, plus the fact that earworms tend to have lyrics. One survey by Williamson's group in the UK and a psychologist named Lassi Liikanen from Finland combined data from thousands of participants and examined the way people already responded to earworms. They found that people tried two main things: distraction and engagement, both of which seemed to work. Distractions that were kind of similar to the earworm were most effective, like listening to a similar song. Some participants even reported listening to so-called Cure songs. Not like the band The Cure, though that could work, but particular songs that people said would push their earworm out without becoming earworms themselves. The researchers couldn't explain why these specific songs didn't become earworms, since virtually any song can, but they didn't. Engagement, on the other hand, tries to take advantage of the Zeigarnik effect. Lots of people know the first verse and chorus of songs, but they might not know the second verse. So their brains can't complete the task, and the chorus gets stuck in an infinite loop. That's why engaging with the song by singing along or listening to it often made it go away. Though the researchers did note that a lot of people liked their earworms enough to not bother doing anything about them. But it was that 2012 Lady Gaga Beatles study out of Western Washington that had the most interesting solution to the earworm problem. The study was broken up into a few different experiments. In each, the researchers would play either top 40 songs by Taylor Swift, Beyoncé, and Lady Gaga, or classics by the Beatles in a certain order. The participants were then asked to solve a puzzle. In one experiment, these were Sudoku puzzles. Another used anagrams. While they were solving the puzzles, the songs would tend to pop back into their heads. The researchers wanted to know if the difficulty of the puzzles would make a difference in the songs becoming earworms, and whether it mattered if the puzzles involved letters or numbers. Turns out both of those things were important. Puzzles that were too easy weren't distracting enough to push the involuntary songs out of people's brains, but neither were puzzles that were too hard. That might seem counterintuitive unless you've ever played a tough level in Candy Crush and just given up in disgust. When a task is too challenging, you can lose interest, and the earworm sneaks back in. Moderately difficult puzzles seem to hit the sweet spot, taking up just enough mental resources for people to forget about the intrusive song. Also, the word puzzles worked better than the number puzzles, something that a bunch of earworm studies have noticed. The researchers think that's because most earworms are songs that have words, so your brain treats them as a type of verbal task. But when it's time to solve the word puzzle, your brain needs to use the same resources, so it dumps the earworm to focus on solving the puzzle. So there you have it. Next time you have an earworm you need to get rid of, solve a somewhat difficult anagram. But in case you don't carry those around with you all the time, the researchers suggest just reading something, as long as it's engaging enough to push the earworm out of your working memory. And if you find yourself getting earworms a lot, there's no need to worry. Music is everywhere, piped into department stores, elevators, out of your phone when you're on hold with customer service for 2 hours. It's no wonder we get songs stuck in our heads when we hear them constantly. And it's also possible that we've trained ourselves to have a good memory for music because oral traditions go back far longer than any writing system. For a long time, humans used songs to remember things on purpose. So the next time you're hearing some 80s one-hit wonder for 36 hours straight, it's not that there's something wrong with your brain's just really into music.
Thanks for watching this very jingly SciShow compilation, and a special thanks to all of our patrons who supported the show all through 2019. You can get in on the action for 2020 and join our community of awesome people at patreon.com/SciShow.